Okay, on questions 20 and 21 from the geometry homework, the directions say list each quadrilateral for which the statement is true, and the statement in question 20 is the diagonals bisect each other. Now again, this is why you have to be very, very familiar with your properties. That was a property we learned with parallelograms. With parallelograms, diagonals bisect each other, so you can either write out parallelogram or use the symbol they've used for parallelogram. Now, also, you have to be familiar with the definitions and properties we learned today. Today we learned about special parallelograms. The special parallelograms are rectangles, rhombuses, and squares. Okay, so if parallelograms have diagonals that bisect each other, and a rectangle is a parallelogram, then a rectangle has diagonals that bisect each other. That also then must be true for a rhombus, which is a special parallelogram, and also for a square. Now, diagonals bisecting each other, that means that those two diagonals, say in a parallelogram, not special, just a normal one, that we have a diagonal that measures 8, we have a diagonal that measures 10. Well, if they bisect each other, it bisects the diagonal that's 8 units long into two pieces that are 4 units, and the one that's 10 units long into two pieces that are 5 pieces. Now, in question 21, it says that diagonals bisect opposite angles. Now, this is only true if all of the sides are congruent, because if you were to draw one of these diagonals and form two triangles, the only way that you can have congruent angles is if those angles are across from congruent sides, and the only way that will work, again, is if all sides are congruent. That is true in both a rhombus and a square. Again, you need to be very, very familiar with your properties. That is a property for a rhombus and a square, and again, if tomorrow you need an explanation or an illustration as to why that's true, please just ask. Very quickly again, if you take a look here, a rhombus, I guess, this will do. If we have a rhombus that's 4 units long on each side, and we were to draw a diagonal, we've created two triangles. Again, inequalities in one triangle. This angle here, which is across from 4, must be congruent to this angle, which is across from 4. Same thing here. This is across from 4. This is across from 4. They have, not only do they have equivalent legs, they have a hypotenuse, not a hypotenuse, but a third leg that's also congruent. So we end up with is this. With a square, it's going to have to be 45-degree angle, given the properties of right triangles. But that's a quick illustration. And again, if you need more, please just ask me again tomorrow, and we'll discuss that further.